Okay, good day. Today we will be studying. We're now in chapter 15, and we're going to discuss about the kinetics of a particle, about impulse and momentum. Okay, for the objectives of this chapter is to develop the principle of linear impulse and momentum. Now, this is applicable in solving problems that involve force, velocity, and time. Okay, so we'll be studying about momentum, impulse, and the conservation of linear momentum for particles. We're also going to analyze the mechanics of impact, okay, and also introduce the concept of angular impulse and momentum. So, uh, in order to derive the principle of linear impulse and momentum, we'll use the equation of motion. Okay, so the equation of motion states that the summation of the mass and acceleration, the force that you apply to a particle will result to a acceleration, no, directly proportional sila. And the constant of proportionality is the mass. So therefore, you have summation of forces is equal to mass times acceleration. But we can write this acceleration term in terms of dv over dt. Now, if we're going to integrate uh, this term f, the force multiplied with the time, we're going to integrate that one, and also we're going to integrate mdv. But since ang maximum is constant, so we will just put this outside of the integral. Okay, now if we're going to evaluate this one, this will result to this equation, summation of the integral of force times time is equal to mv2 minus mv1. Now, this term mv2, mass times velocity, is what we call the momentum. Okay? This is a vector, and since ang imong mass is scalar, so ang direction sa imong momentum is the same sa imong velocity. Okay? And this is denoted by symbol L. Okay? This is denoted by symbol L. Now, kaning nga term, summation of force times time, this is equivalent to the impulse, linear impulse. Okay? So this measures the effect of a force during the time the force acts on the particle. Okay? So, kaning nga equation is what you call the principle of linear impulse and momentum. You just transpose this m by 1 to the left side. So, it will result to this equation. Now, this equation states that the initial momentum of the particle, okay, so if the particle is moving to the right, and then you apply a force, no, at a certain time interval. So, ang change sa momentum ana will be mv2. So, therefore, ang final nga momentum nimo is just equal sa initial momentum plus the impulse. Okay? Now, in order to evaluate this integral, dapat ang f nimo must be a function of time, no? Or other case, force must be constant, no, para ma-integrate nimo. Other than that, no, kung ang imong force is not a function of time, dili nimo ni ma-integrate. Okay? Okay. So, this is the vectorial representation. Now, we can actually break out this one into the Cartesian components x, y, and z. Okay, so para mas simplify ang atong pag-solve ani later on. So mvx1 plus summation of forces along x times dt is equal to mvx2 and so on. Okay, so component by component, you get the forces along x, multiply nimo sa momentum along x also, or add nimo sa momentum along x to get the final momentum along x, along y and z. Now, it is very helpful to draw the impulse and momentum diagram. So this is the impulse and momentum diagram, no? It shows that this is the direction, no? Initial momentum. So diri ang direction nimo, no? Okay, diri man imong velocity, so diri pa ang imo ang momentum. Now, kung i-add na nimo, add with the impulse, i-applyan man din niya og impulse pa down kani imong particle. So unsay mahitabo na naman ang final nga momentum karon. So diri na, no? Ginsa nimo ni pagkuha nga diagram and direction, imo ning pwede mo ning vectorial add nimo vectorially, no? So, kung i-add nimo ni dire tip to tail method, kuha nimo ni final momentum. Okay? Okay, since gi-derive nato ni siya, sa Newton's second law of motion, no? So this is just another way, actually this is just another way of solving, but useful ni siya in terms kung ang imong given is force, velocity, and time, no? Kung kani ang involved or kani ang pangitao nimo, mas dali nimo ni siya gamiton. Okay, so we'll have an example later on. Okay, so let's have an example in order to apply the principles of linear impulse and momentum. Okay, so you have a 100 kilogram crate is originally at rest on the smooth horizontal surface. Now, if a towing force of 200 Newton acting at an angle of 45 degrees is applied for 10 seconds, determine the final velocity and the normal force which the surface exerts on the crate during this time interval. Okay, so we are asked to find the final velocity and the normal force. Okay, so actually we can solve this one using directly the equation of motion. Force is equal to mass and acceleration. However, it is convenient to use the principle of impulse and momentum. Okay, so we will apply the principle of linear impulse and momentum for x and y components. So you have m v sub x1 plus summation of forces along x dt is equal to m vx2. Okay, so since it is stated that it is at rest, so this is 0. Now we will draw first the free body diagram. So we have the force, we have the weight, 100 kilograms, so this is 981 Newton, and the normal component. We don't have the frictional force because it is stated that it is a smooth horizontal surface. Okay, so what are the forces that are involved for long x? You have only the towing force. So you have, now since this is constant, so pwede rin yung ipagawas. So this just becomes fx t2 minus t1. Or in this case, from 0 to 10 seconds. So this will become 200 cosine 45 times 10 seconds. Okay? Is equal to m. We will, the unit ani is Newton second is equal to 100 kilogram V sub x 2. Okay? So, pila yung answer ani? V sub x 2 is just 14.1 meter per second. Okay? Okay. The second component that we're going to find is the normal. Again, we can use the principle of linear impulse and momentum. So you have mv sub y1 plus summation of f sub y dt is equal to m v sub y2. Okay, since there is no motion along y, so zero ni. So you have only NC times 10 plus 200 sine 45 times 10 minus 981 times 10. Okay? Or tanggaling 10, pwede na may divide of 10. Therefore, normal component is just 840 newtons. So again, you can solve this one using Newton's equation of motion. No, so but it will involve two-step nga process, no? Two-step nga process. Kung pa nimo ang acceleration along x, okay, summation of forces along x. So kanimo makuha acceleration, and then imo na pud ning okay, so it will involve two-step process, whereas kani diretso ra, no? So mao ni ang isa sa advantage sa paggamit aning principle of linear impulse and momentum if you are given force, velocity, and time. And also, maggamit natin siya later on in analyzing mga mechanism of impact. So there are plenty of examples, just practice.